Recording. All right. So before I begin this brand new unit, how many people have this up in front of them? Can you hit yes? I'm hoping to see a lot of yeses. Okay. If I don't see a yes, I think maybe you're not even there. Okay. How many people have this up in front of them? Please hit the yes button. Keep them coming. Come on, come on, come on. Here we go. Leave it lit up. Yes, please. Don't take it down. Just leave it up. Yes. Okay, we're at like 75%. The rest of you guys, no. I'll give you another second. Okay.
Yeah, I'm not seeing that. Where is it located?
Okay, good. Thank you for bringing that up. It is modules right here, 10.5 to 10.9, Monday, 1.1 task. Let me know, Alex, if you're able to see it there, or anyone else if you're having trouble. Okay.
All right, I got it. I got it.
You got it? Awesome. Okay. I'm going to pull the chat up. Brandon, keep monitoring that chat, but let me. Why did we skip the first page? Oh, okay. Ashton, I'll explain that. Thank you. Why aren't you on number 1? I should have explained that. Yeah. All right. Let me tell you why. All right. So, as a lot of you guys noticed, this is what it looks like, right? At the top. When I came in today, I started working this problem out that they have as a warm-up. My guess is that half of you would find it very hard and confusing. That's not any kind of a way that I want to start our unit together. So we'll probably go back and fill it in later. Or if you felt like doing it later, you absolutely could. But let's not start the module with confusion. Okay, let's just start right here where the task really begins. Okay. All right. Ready? Here we go. All right. Cell phones often indicate the strengths of a person's signal with a series of bars. The logo below shows how this might look for various levels of service. And then it has figure 1, 2, 3, and 4. Assuming the pattern continues, draw the next figure in the sequence. So if you're doing this on paper, it's real easy, right? You just start drawing blocks, okay? If you don't want to flip back and forth, do transfer it over later so I can see that you've done it. But this is an easy one to do on paper if you need to, okay? So go ahead, draw what you think the next one would look like. Number 2, how many blocks are in figure 10? Try to answer that too, okay? Let's take like 3 minutes and let's see how far you can get on this first page. And while you guys are doing that, I'm gonna go to GoFormative and just see how many of us are able to have this up, because I was concerned that maybe we didn't have enough green checks there. So go ahead, take a few minutes, go for it. If you are doing it on paper, like at least write like, the blocks down for number 2 so I can see that you're with us. Bay, I'm just reading your questions or your question. Yeah, it's the total number of boxes in figure 10 for number 3, not just the bottom row. Brandon was right. Ashton, you can go on ahead, work through 3 and 4 and 5 and 6 if you can. Brandon was right about that too. Brandon, all right. You know, if I'm ever sick, Brandon, maybe, you know, nah. Yeah. Okay, guys, let's draw everybody together here. I'm seeing some good stuff when I'm looking at your guys' work. Assuming the pattern continues, draw the next figure in the sequence. So it was like 1, and then 2, 2, 3, 3, 4, 4, and then it had 5s on it, right? For number 2. So the next one would have been like 5 blocks over on each side. And when I look at it, like I can tell that you guys are picking up on the pattern there. So I don't, judging on the accuracy of like what I'm seeing here in front of me, like everybody got it pretty much. So I'm not going to spend too much time drawing on 2. How about 3 though? How many blocks are in figure 10? I'm seeing a lot of interesting stuff on my screen. All right. I mean, you guys got to realize like normal school, you're like, I can't see all this stuff, like what's on your paper. So this is kind of cool to be able to see how people are thinking about this. Some people just chose to like straight up draw it. Okay. So they noticed that, you know, for figure 10, hold on a sec. Where's it letting me draw? So they noticed that like for figure 10, like this would have 10, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then this would go up 10, you know, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then they filled in everything in here and they counted. Okay. Totally fine strategy. And I see people sharing a really good number in the chat, 55. Okay. Now, obviously, we don't want to have to draw it every single time because it's super time consuming. And what if it was like figure 55? Like that would just be crazy to draw. So I see some other ideas in there. Do any of you guys want to share your idea about how you thought about figure 10 without drawing out the entire picture? If not, I'll have Brandon or Ethan share. So Brandon, Ethan, be preparing yourselves. But do any of you guys want to share about how you might do that?
So the regular the first one is like figure 1, then figure 2, then figure 3, then figure 4. So diagonally you add 1 block, which is like if you added to figure 5, which is 1 more block, and then there's like 5 blocks diagonally, and then you add 5, and then like you added 6, which is 6 more blocks on the right side, so then you add 6 more. So whatever the total is for 4, you would have added 5 more, and then 6 more, then 7 more, then 8 more, and so on.
On each continuous one. So did that get you 10?
No.
Were you able to get 55 using that?
Yep.
Okay, cool. Thank you. Dominic, explain your strategy. Thank you, Julie. That was good. Go ahead. Can you, Dominic?
Yes, I can. What I did was the number of the figure.
I can't hear you anymore. Maybe it's me. You there? I'm not sure if it's just me. He may have lost connection. Yeah, he may have lost. I think you lost connection there, Dom. Anyone else want to share? Maybe we'll get him back.
Hello?
Yeah, I can hear you now.
All right. So the figure number is the last line of the blocks. So
Right.
figure 10, there'd be 10 blocks in the last line. So I kind of just added all the lines up and I got 55 that way.
Oh, because it's going to go 10, 9, 8, 7, 6, 5, 4, 3, 2,
Yeah.
1. Oh, nice. I like that way. And you got 55 doing it that way, right?
Yes, I did.
Okay. What's another way to do it with even less work, maybe? Someone said they used a table. I would love to see the used a table way. How could we possibly make this a table? Can I get one of you guys to share? If not, I'll call in a student aid. How would we make a table?
What I did is like I had like 2 columns of the figure number and then the amount of like squares or like blocks in the figure. So
Okay.
for figure 1, there's 1, and then for 2, you add 2 more onto the previous number, and then just so on and so forth. So then that got me 10 pretty easily without having to like draw them because that
Okay.
took a long time.
Yeah. So those of you guys with paper, or not, if you could write this part down, because this is really what it's getting at. Although I was very impressed by some of those visual examples. You have like your figure number and then your blocks. Okay. Some people do the tables like this. I find that to be more confusing, but whatever you want to do, I guess. And then figure 2 had how many blocks? 3. And figure 3 had what? 6.
6.
Figure 4 was how many blocks?
10.
10. Okay. Cool. All right. And then figure 5. And so on and so forth. What was the answer for 5 when you guys drew it? How many did 5 have?
15.
It had 15, right? Okay. So how did you use a table to solve this one? Did you just carry the table out to 10? Who was giving us that again? I can't remember. Maybe one of you guys that made a table. How would you carry this chart out to 10? Like, what's the pattern? Can you guys see the
Oh,
pattern?
You
Wait,
just
yes.
keep adding.
Yeah. What do we keep adding? It's hard to describe.
Like, well, 10 to 15 would be +5, and then it's +6, +7, +8, +9.
Oh, okay. So figure 7. Wait, that's wrong. Don't write what I have on there.
No.
Yeah. So I think what you're saying is that this one added 2, this one added 3, 4, 5, 6, like that. So what's figure 6?
Yeah.
What's figure 6?
21.
Yeah, 21.
Then we're going to add 7, and that's going to give us 28, right? And then we're going to add 8, and that gives us 36. Then we're going to add 9, which is going to give us 45. I'm running out of room. And then figure 10 is 55. And it added 10. Okay. With a, hold on. With a green check, how many people understand the table that I have up there? How many people can follow the pattern in the table? A few more, hopefully. How many people can follow my pattern? write it on paper. If you can't switch back and forth, make sure to write that down on paper. Okay. All right. So it asks you to write a rule in number 5. Is that right? Let me see your answers and see if anyone got the next one, which is, interesting. 4, 5. Oh, okay. So actually, now that I'm opening this up, right here on 4, we have that table. So can you guys open this up, please? If you haven't already. And then it was just like 1, 2, 3, 4, 5, 6. So you remember the goal today, like finding a pattern? This would be like a typical problem that I would look at probably to grade. Because look, you're showing the pattern in like all these different ways. You're describing the pattern. Like this is just like, this would be a really good problem for me to look at, okay? In other words, do a really good job on this problem, okay? Now I don't have those numbers up there. Brandon, what, do you have them or someone else? What was it? It was 1 and then 1, right? 2, how did it go? 2.
3.
Yep. 3.
And then I believe it was 6 for 3.
Does that look good?
Yep.
You can see them, right? Like you can see everything I'm doing.
I can.
Okay, cool. All right, let's go ahead and graph those. So now we're gonna graph the pattern. So this is gonna be like an XY table. So we got 1, 1, 2, 3, 3, 6. And 6 goes off the page. Just gonna go. Okay. Is this pattern a linear pattern? Yes or no? Oh, good. Thank you for communicating with
No,
me.
that is not linear.
It's not.
It's exponential.
Let's talk about linear first, then we'll get to the next one. It doesn't look linear because a linear makes a line, right? Okay. So in your patterns, do you remember those other numbers that I had over here that were like 2, 3, 4, 5, and 6? This might kind of serve as notes. This is called a first difference. Okay. So if the first difference is constant, like it's just the same number, like if it was plus 3, plus 3, plus 3, plus 3, it's linear. Okay. Now we can see here that it's not. Okay. So you might write that down. Like if the first difference is the same number, or if the first difference is constant, I might be telling you too much here. It is linear. All right. What about exponential? Someone said yes to exponential. Does someone want to say whether or not they think it's exponential? You might not remember exponential from last year. It just looks exponential. It does. It looks like the curve is going up, right? Yes, because the number you're adding is not constant. Yeah, it's not constant. It's not linear. That's true. I hear true, true, true. Brandon, is this exponential?
I would lean on the side of no.
Brandon, I'm going to stay with you, okay? Let's say it goes like 1 and then 3. Why is this one exponential? Can you even see that?
I can.
This is exponential, right?
Yep.
How can we tell that my little table over here is exponential?
Because its numbers are growing way too fast.
What's it multiplying? It'll have a constant multiplier.
It's a multiplier of times 3.
It has a constant multiplier. Bay, that's a very good answer. That's what they want you to think right now. Like it's quadratic or something. Like I don't really know what quadratic is, but yeah, maybe. Like that's kind of what they want you to discover. Okay. So it looks exponential, but if you were to really carry it this way, this graph would come up like that and it's quadratic, but you don't need to know what quadratics are because that's what this unit is about. And this is the first day. Okay. But yeah, it is quadratic. So we don't know how to come up with a rule for quadratics yet. Okay. But if you would like to try later, you certainly can. And I've had kids get it before and it's pretty impressive at this point. But this is going to be optional for now. Okay. But try if you want to. All right. Optional. If you want to try to get a rule there, you can. Now, here's where I'm not just going to give you the answer. Okay. And this is something that I would really probably grade because this shows me that like you've picked up what you're supposed to pick up. Describe or a description of the pattern. How is the number of blocks growing as the figure number changes? Okay. So think about how we got these numbers in the table and just put it into your own words. And that gets you, if that's what I were to look at, that would get you a pretty good grade for the day. Like what's going on here? How are we getting those numbers? Because we know we're not multiplying by 3. We know we're not adding 3 each time. Like something different's happening there. It still has a pattern. How would you describe it? Like type that in there, write that in there, whatever. Anything you'd add to that, Brandon?
I don't know what to add.
Okay,
I think it's pretty good.
Yeah, I think we're good. I think we're good. I might start class tomorrow, like saying what the explicit rule is for that one, or see if anybody got it.
Hey, Bay, that's a nice Neko.
We're almost done, guys. Almost there. What's your cat's name, Bay?
This is my friend's cat. She's named Olive.
Nice. Okay. I'm going to play the video after number 6. If a few of you guys could comment in the chat about how the volume and stuff is, I'd appreciate it.
These notes are on the differences between linear, exponential, and quadratic functions. So we talk about rate of change for all three of these functions, and we talk about them in slightly different ways.
How's the video and the audio? Anybody? Hello?
Audio's all right.
Audio's all right. It's quiet but good. All right, let's see if I can turn it up. Specifically the audio, which is perfectly fine on my end, or the fact I don't know. I'm gonna play it and just hope that it's good, but you guys can always play these on your own too later. Here we go. I'm gonna turn off my video. If you guys could too, that seems to help.
The rate of change for a linear function is constant. And what that means is that if I go from 1 point and I go 1 over, that's going to be the same rate as when I go from here 1 over as this rate here. That rate doesn't change regardless of what 2 points I pick. As long as I reduce the fraction, they will all be equal. The equations for these have a highest term that is x. So you have seen equations of this type written in mx plus b form. You've seen them written in standard form. And you've also seen them written in point slope form. Either way, any of the ways these are written, you'll see that the x, the highest power on this x, is a power of 1. And we don't write that because it's a nicety. We've assumed that everyone understands that that power there is 1. So the highest term is an x to the 1. If we're going to be very careful about that. Now, for exponential functions, our rate of change, we can talk about it in two ways. In Math 1, we often talked about it as being a constant factor. It turns out that exponential is a little bit extraordinary because the rate of change is actually an exponential rate of change. Turns out that if I just keep finding rates of change over and over and over again for exponential, those rates of change will continue. Each time will still be in the pattern of an exponential. For exponential equations, for the graphs, they have this general shape. So they flatten out someplace and then they continue getting higher and higher on the other side. For exponential, the equation x is an exponent. So that means I could have something like y equals 3 to the x, or I could have f of x equals 1/2 times 4 to the x. Either way, the x in the equation is an exponent. The last function that we're looking at and comparing are the quadratic functions. For the quadratic function, it turns out that the rate of change is linear, meaning the second difference is constant. So when you're looking at a table, you have like a quadratic relationship, and when you look at the first difference, it's a linear, and when you look at the second, it's a constant. It's the same number being added or subtracted every time. In this case, for the graph, we have a parabolic shape, which we call a parabola, and it's a U shape. And it can be a U going up, a U going down, it can be a U moved over, up, anywhere. For the equation, the highest term is an x squared. So you could have y equals x squared, or you could have y minus 4 equals 3 times x minus 4 squared. So when I multiply this out, I'm going to have an x squared, and we'll look at that further in the course of Math 2. Let's do one more example. So y equals 1/2 x squared minus 4x plus 10. All of those are quadratic, represent quadratic and parabolas.
Okay. All right, I'll turn my video back on here. Bay, I was jealous of your cat, so I went in and I grabbed one of my dogs. This one's Masuka. Remember, he's the lighter brown one. Yeah, he's a good boy. His brother's really lazy. He's upstairs sleeping, so ugh. Needs to brush your teeth. Okay, so we're done. So here's what we need to do. So you can stay if you want, or you can write this down and go. All right, Zoom share. There it is. Okay, so just finish number 7 and number 8 on the task on your own. Those should go really fast. And then just do the go. Don't do the set, or that should say the set or the ready. Set or ready. Okay, just 7, 8, go. That's all you need to know, 7, 8, go. And if you would like to stay and do some of that with me, or if you want to stay and try to get the explicit equation for the blocks on the task or something, you can, or you can like stay and answer any questions that you want. But if you want to leave, just say goodbye and make sure to do that tonight though, okay? Stay caught up.
All right. I'll see you later.
If you're leaving,
Bye.
have a great day. See you later.
Thank
See
you.
You're welcome.
Thank you.
Bye.
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 Also love your dog.
Oh yeah, he's a good boy.
All right, Mr. Thacker.
Yeah, Moses, how you doing, man?
So am I able to turn in the late work before like the weekends?
What were you talking about, Moses?
And so like, am I able to turn in like the late assignments before the grading day happens on Friday?
For module 9?
Yeah.
You took the quiz, right?
Yeah, I got 13 out of 15.
You got what?
13 out of 15.
Okay. Right now, I feel pretty good about that with your probability. Just worry about the assignments from 1. Okay, I don't want you to worry about probability stuff. Okay?
Like today's assignment?
Yeah. Did you understand today?
Yeah.
Okay. Let's not worry about 9 right now. Let's just focus on 1. Okay.
All right.
Yeah, you should have a pretty good grade. Have you looked at your grade in Synergy? If you got 13 out of 15, you should have a pretty good grade.
Well, thank you, Mr. Thacker.
Yeah, thank you, man. See you later.
Yeah, you have a nice day.
Yeah, you too. All right, who's up next? You guys want to do some problems? You got some questions? We got like 10 people on here. Anybody? If it's a math problem, you could just name a problem and I'll do it. If you want to do something on the go, if you want to do something from the task. Okay. Curious about the equation. Equation for number 1. All right. I'm going to put my dog away. I'll be right back. I like that problem. We can do it. Hang on. Okay. Can you see that okay, Gemma?
Yeah, I can. I understood the table. I was just wondering about the quadratic equation.
How to write it out?
Yeah.
Yeah. All right. So they're not going to expect you to do this until like halfway through the chapter. And this would be teaching you like way too much for one day, probably. But we could do it. I can just straight up like tell you how to do it. I think at this point, they just want you to guess and check and see if you can get a formula that when you plug in 2, you get 3. And when you plug in 4, you get 6, and 5, you get 10, right? So, Brandon, are you still there?
Hello.
How would you do? I mean, I know the way that I would do this. Is there a simple way that you would write an equation for this data that we have here?
I don't think they learned recursive functions yet.
Yeah, I don't.
That's
think
how
so.
I did it.
But what about to do the explicit? So you would have to know like this is the Jim, are you still there?
Yeah.
Okay, you're gonna get a crash course here, okay? So does that look familiar to you at all? Have you ever seen that?
No, not really.
Okay. So you know how we have this?